As we saw with the sequential search, the potential having to search all the way through a list of values isn't very efficient, but one way we can make it better is by sorting the values into an ordered list. Now that raises another question. How do we do that, and what's the most efficient way to do that? And there's a couple of answers to this question and a couple of alternative algorithms we can use. But the oldest and simple searching algorithm is the bubble sort. The bubble sort passes over a list of items, comparing two at a time. If the one on the left is larger than the one on the right, it swaps them. Then it moves forward one and does the same thing until it reaches the end of the list. Now the largest number in the array is at the end of the list, but the rest still aren't in order. So it does this same thing until it reaches the second last number, putting the second last number in order as well. It repeats this until all the numbers are in order. So let's code this up. Again, we're starting with a loop. So for, we're going to have a variable called pass number in range, and we're going to start our range at the end of the list, and we're going to decrement down to 0. So the pass number is going to be the position of the number that we're going to currently put in order in the list. So we're going to start with len of numbers minus 1, because of course we start at 0. We're going to decrement down to 0, and we're going to decrement down 1 each time. Okay, so we're opening up that list. Within this list, we want another for loop. And this time, we're going the position of the two items that we're comparing all the way up the list. So for I in range, starting at 0 and going up to pass number. Now we're going to do our comparison. If numbers of our current position we're looking at is larger than the number next to it, we want to swap them around. So numbers 1. Okay, so this should pass out. This should swap our numbers over. Okay, so let's check that out, that it orders up our list. And if we look down here, it in fact gives us an ordered list of our 20 values. Well, we've got our ordered list, but what was the efficiency of getting it? Well, the big O number is n squared, because no matter what, we pass over every number in the list except for that last one for each pass over the list. But there's a simple way we can make our bubble sort significantly more efficient. That's by checking if all the numbers that we're passing over are in order and that we don't need to make any more changes. This variation of the bubble sort is called the short bubble sort. And to do that, we just need to add a couple of new features. The first feature we need to add is a variable up here asking if the pass we just made is all ordered. So we're going to start that, assuming that it is, because we haven't done any changes. Now, if we make a change, it means it's not ordered. So we're going to change ordered into false, meaning it's not ordered. Now that we've checked all the numbers that we're passing over to see if we're ordered or not, if we are in order and we didn't make any changes and we didn't make any changes, meaning all the numbers in the entire array are in order, we can just break out of our outer pass number for loop here. Again, look at that. Our whole list is ordered, and that should have happened significantly quicker. So if you probably guessed, this is far more efficient than the original bubble sort. Best case scenario is now n, because we'll pass over all the list once, but if they're all in order, we'll break out of the for loop. The worst case scenario is still n squared, because it's still going to go over all the numbers. But that little change has the potential to make a big difference. But like I said, bubble sort is still the most inefficient of the sort algorithms. In the next video, we'll graduate up to the selection sort, which is a little bit more complicated, but is also significantly more efficient.